Hello everyone, I am Sakshi Vinod Patil. I am doing ISE 1 Activity 2 presentation on AlexNet architecture. So let's see the AlexNet architecture. So AlexNet is an image classification model that transformed deep learning. It was introduced by Geoffrey Hinton and his team in 2012 and marked a key event in the history of deep learning, showcasing the strengths of CNN architectures and its vast applications. So let's see its diagram and its working. So it is basically it takes image as an input and performs some operations which converts the image size to the minimum. So first layer is input layer. The network layer take, takes an input image of 224 by 224 by 3. That is, it takes RGB images. Second, the convolution layers. The first five layers are convolution layers that apply filters to the input image to detect basic features like edges, textures, and more complex patterns as the layer processes. For this, the ReLU activation function is applied. And second layer is max pooling layer. After some convolution layers, max pooling layers reduce the spatial dimensions of the feature maps, helping reduce computational and preventing overfitting. Then second last one that are fully connected layers. After feature extraction, the network flattens the output into a 1D vector and passes it through three fully connected layers that refine the learned features and perform classification. Then dropout. To avoid overfitting, dropout is applied during training, randomly disabling certain neurons in the fully connected layers. Then the output layer. The final fully connected layer produces the classification results with each output node corresponding to a specific class label. So let's understand by diagram. It takes the input as an image of size 224 by 224 by 3. Then the five convolution layers are applied on that image. After that, some max pooling layers are also applied on them, and then the image passes through the fully connected layer so that we can lastly obtain the output size of the image. Then the pros of AlexNet architecture. AlexNet significantly improved image classification accuracy compared to previous methods, winning the 2012 ImageNet competition by a large margin. The use of ReLU function instead of traditional activation functions like sigmoid and tanh sped up training and helped the network learn more complex patterns. By using GPUs for training, AlexNet reduced the time required to train large models, making deep learning more feasible for large datasets. Dropout helps prevent overfitting by randomly deactivating neurons during training. Then the cons. AlexNet has a large number of parameters, requiring significant memory for training and storage, making it resource intensive. Second, due to the deep and large architecture, AlexNet can be slow in interface. The model works best with large datasets like ImageNet. For smaller datasets, AlexNet might not perform as well and could overfit. Then last one, newer architectures have more advanced techniques like residual connections and better optimization that AlexNet lacks. Then the some applications of AlexNet. AlexNet is widely used in classifying images into categories, such as identifying animals, objects, or scenes in photos. Second, in healthcare, AlexNet is used to detect diseases in medical scans like X-ray or MRIs. AlexNet can be applied in security systems to identify individuals by analyzing facial features used in applications like surveillance cameras or phone unlocking systems. Then the conclusion. AlexNet was a groundbreaking architecture that significantly advanced the field of computer vision by utilizing deep convolution layers, ReLU activation, and GPU acceleration. It achieved a remarkable accuracy in image classification tasks, paving the way for more complex and efficient neural networks. While its memory is computational requirements are high, its impact on AI research and real-world applications such as medical image analysis, autonomous vehicles, and facial recognition has been profound. Although newer models have surpassed it in efficiency and performance, AlexNet remains a key milestone in the evolution of deep learning. So that's it. Thank you.